Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And this short video is going to detail how to find the inverse of a matrix. The matrix that we're going to be dealing with here today is a 3 by 3 matrix, and this particular matrix has been taken from the text by Anton, which is titled Elementary Linear Algebra. Okay, so if you're looking for some more information, maybe have a look at that particular textbook. We're going to apply what's known as Gauss-Jordon elimination to this particular matrix, and more importantly, we're going to transform this matrix into what's known as reduced row echelon form using what we call elementary row operations. But I suppose the first thing that we should do, step one, is we should convert this matrix into what's known as the augmented matrix. Okay. The augmented matrix is simply our matrix augmented with the identity matrix. So in this case, our matrix is 1, 2, 3, 2, 5, 3, 1, 0, 8. And what we do is we augment it with the identity matrix, which is 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, so that's the first step. The next step, step 2, well, there's going to be many applications of this particular step. Step 2 is we apply what's known as elementary row operations. Elementary row operations. Okay. That's where we add multiples of rows to other rows, and we subtract multiples of rows with other rows. Okay. I suppose the goal that we aspire to is to convert this matrix here into the identity matrix. Okay. So what I'd like to do is to convert this matrix so that I have leading ones along the main diagonal, and all other entries in the matrix have zeros. Okay. I need a leading one on the first row, in the first entry. I've already got that, so that makes our job a little bit handier here. So this one matches this one here. So what I should proceed to do is to change all the entries below this particular entry into zeros. And what we can hopefully see is that if I want to convert this 2 to a 0, if I add or subtract twice row 1 from this row, the result will this 2 will become a 0. So our first elementary row operation is that row 2 is going to become row 2 minus twice row 1. Okay, so let's see what the effect of this particular transformation is. Okay, so the only row that we're going to change is row 2. Row 1 and row 3 will remain the same. So let's put back down row 1 and row 3. So we have 1, 2, 3, 1, 0, 0. We have 1, 0, 8, 0, 0, 1. Okay, and row 2's values are going to become, the new row 2 values are going to be the old row 2 values minus twice row 1. Okay, so the first value is going to be 2 minus twice 1 gives us a 0. The next value is going to be 5 minus twice 2 gives us 1. And the next value is going to be 3 minus twice 3 gives us a minus 3. The next value is going to be 0 minus twice 1 gives us a minus 2. The next value is going to be a 1 minus twice 0 gives us a 1. The next value is going to be 0 minus twice 0 gives us a 0. Okay, so what we've done here is we've managed through an elementary row operation to reduce the first entry on the second row to be a 0. And now what we'd like to do is to reduce the first entry on the third row to be a 0. Okay, and what we could do here is we could say, well, if we add on a multiple of row 1 to row 3, that will help us along the way. So the operation is going to be row 3 becomes the old value of row 3 simply minus row 1. Okay, so the only row that we're operating on is row 3. So let's just put down row 1 and row 2. So 1, 2, 3. 1, 0, 0, as these don't change, 0, 1, minus 3, minus 2, 1, 0. And now what we have is we have our operation on row 3. So the new value in row 3 is equal to the old value in row 3 minus the value in row 1. So it's going to be 1 minus 1 gives us a 0. It's going to be 0 minus 2 gives us a minus 2. It's going to be an 8 minus a 3 gives us a 5. It's going to be a 0 minus 1 gives us minus 1. It's going to be 0 minus 0 gives us 0. And it's going to be 1 minus 0 gives us a 1. Okay, so what we've done now is we've reduced row. I suppose we reduced the first column so that we have zeros under the first leading one. Okay, so now what we need to do is we need to proceed so that our next leading one, okay, and the second row has zeros below it. And the question is, how do we convert this into a 0? And more importantly, how do we convert this into a 0, but through the operation, we don't want to affect this 0 in this particular entry. Okay, so hopefully what we can see is that if we add twice row 2 to row 3, this will convert this minus 2 to a 0. So what we have is that row 3 becomes row 3 plus twice row 2. Okay, so the only row that's changing is row 3, so row 1 and row 2 are the same, so let's put them down. It's 1, 2, 3, 1, 0, 0, 0, 1, minus 3, minus 2, 1, 0. And our change is to row 3. So row 3 becomes the old value in row 3 plus twice row 2. So it's the old value plus twice row 2 is 0 plus 0 gives us 0. It's minus 2 plus twice 1 gives us a 0. It's a 5 plus twice minus 3 is a 5 plus a minus 6 gives us a minus 1. It's minus 1 plus twice minus 2 gives us minus 5. It's a 0 plus twice 1 gives us a 2. And it's a 1 plus twice 0 gives us a 1. Okay. So what you can hopefully see is that the matrix is starting to form or starting to transform into the identity matrix. We've nearly got leading ones along the main diagonal, bar this one that's a minus 1, but we have zeros below the leading ones. Okay, so we'd like to convert this minus 1 into a plus 1. So one of the other row operations that we could do, instead of adding on multiples of other rows, we could simply multiply this particular row by a particular constant. And in this case, if we multiply this row 3 by minus 1, that will convert this one, minus 1 into a 1, this into a 5, this to a minus 2, this to a minus 1. The result will be a leading 1 on this particular row. Okay, so the operation is going to be that row 3 is simply going to be minus row 3, or minus 1 times row 3. So the only row to change is row 3, so row 1 and 2 remain the same. So we have 1, 2, 3, 1, 0, 0. We have 0, 1, minus 3. We have minus 2, 1, and 0. And now the operation, well, the operation converts or transforms row 3. And row 3's new values are going to be minus the values that are currently there. So it's 0, 0, and it's minus 1 gives us a plus 1. It's minus 5 gives us a 5. It's minus 2, and it's minus 1. All we've done was we multiplied row 3 by minus 1. Okay, so we're nearly there. The next thing is we should start now on the third row and start to get zeros above each entry. On each entry that's above this particular third entry on the third row. Okay. So what we could do now is we could say that row 2, if we add on 3 times row 3, so row 2 becomes row 2 plus 3 times row 3. Okay. So the only row to change now is row 2, so the other rows remain the same, so it's 1, 2, 3, 1, 0, 0, it's 0, 0, 1, 5 minus 2 minus 1. Okay. And it's row 2 that's being updated. So the new value in row 2 is the old value plus 3 times row 3. So the new value is going to be 0 plus 3 times 0 gives us a 0. It's going to be 1 plus 3 times 0 gives us a 1. It's going to be minus 3 plus 3 times 1 gives us a 0. It's going to be minus 2 plus 3 times 5, which is a plus 15. So it's a minus 2 plus a 15 is going to give us a 13. Okay. it's 1 plus 3 times minus 2, so it's